All right, this is part 2 of 9.4, measures of variation. And the next question is, how do we find the first and third quartiles and the interquartile range? Whew. Okay, to start this, we're going to look at this beautiful blue stick. Look at that blue stick. I mean, who likes that blue stick? It's amazing. Why are we looking at this? Here's why. If I said, hey, take this stick, and what you want to do is you want to break it into 4 equal sections, right? So you had to split them among people. You were trying to be fair. Well, how would I do that? The first cut I would make would be in the middle, maybe. And I'm not going to do this perfectly, but I would make a cut approximately in the middle. And then I'd take each half, and I'd cut each half also in half, right? Something like this. And as you can see, my computer's totally working. Okay. So let's make sure we have this right. To split this blue stick into sections, section 1, section 2, section 3, section 4, how many cuts did we have to make? If you want 4 sections, you only make 3 cuts. Okay? 4 sections, 3 cuts. So we're going to make 3 cuts to our data. The first one's going to be right in the middle. Does anybody remember the measure of center that's right in the middle? That's the median. And then when we cut the other data, each half of the data that the median splits in half, we're going to cut each half in half. And this is going to be the first quartile. Okay. And and this one's going to be the third quartile. Okay, as you can see, this is totally working. There we go. So in other words, we're going to take all of our data, break it in half using the median. You better order your data from least to greatest, and then cut each half in half to find the quartiles. Let's see how that looks in practice. Okay, first, quartiles. Doesn't that sound like something? Doesn't quartile sound like quarters? How many quarters does it take to make $1? 1 quarter, 2 quarter, 3 quarter, 4. 4 quarters, 3 cuts. So it takes 4 quarters. Quartiles are going to be the 3 cuts you make to split your data into 4 sections, like quarters. The first step is to order your data from least to greatest. Then make a cut in the middle, which is that cut in the middle. Once the data is from least to greatest, that cut in the middle is the median. Then we're going to cut each half of data in half. The cut below the median is called the first quartile, and the cut above the median is called the third quartile. Okay. How many monkeys would 6th graders like to hang out with on a trampoline? I asked some 6th graders. They said 5, 3, 3, 4, 2, 6, 1, 2, 3, 4, 8, and there was no data here. So nobody was recorded. So the first step is to order these data from least to greatest. Remember how I said that's always good policy. The least number I see here is 1. I'm going to cross out 1. I'm going to put 1 here. The next number up is 2. How many 2s? 1, 2, 2 2s. 3s. 1, 3, 2, 3, 3 3s. How many 4s? 1 4, 2 4s. 5, 6, 8. And there was a blank space here, so we're just going to leave that one empty. Okay, now, where do we make a cut on this blue stick? First, the median. I'm going to use this dot method, put dots on the least and greatest values, then go in 1, and slowly make my way towards the median. And it looks like my median cut, and I make a cut right through it. You actually make a cut right through it, is 3. Now that I've made the cut here, now to find the first quartile, I need to split this bottom half of the data in half. So I can do this again. Let's see, 1, dun, dun, dun. Isn't that this 2. So quartile 1 is 2. And then I do the same thing up here, and I make the third quartile cut, and I didn't do it very well. So I'm going to try it one more time. Whoa! And that third quartile was 5. Not too bad, right? Not too bad. So 2, 3, and 5. And the cuts were right on the numbers. Well, I'm going to do the next data set right here. But as you can see, remember how this was blank? Now it's been filled in with a 5. All the rest of the data are the same. So I'm going to use the order I had before, but I need to remember to add another 5. So 1, 2, 2, 3, 3, 3, 4, 4, 2 5s, and then 6 and 8. Okay? Now I'm just going to assume I didn't make any mistakes. I hope I didn't. Let's make sure there's, I guess, 1, 1. There's 1, 2, 2 2s. Yep. 3 3s. 2 4s. Yep. 2 5s, a 6, and an 8. Excellent. Okay, this time, let's find the median. So, boom, boom, da da. Yo, yo, yo. Oh, look at this. Oh, oh no, there's 2 numbers in the middle. What do we do? If we want to find the median and there's 2 numbers in the middle, you find the mean of those 2 numbers. 3 plus 4 is 7, divided by 2 is 3.5. Okay? Now I'm going to put the cut in between 3 and 4 this time. Before, our cut was right on the 3, but now the cut's in between, right? Because the median's in between 3 and 4. So now I look at the bottom half of the data, and I do the same thing. And what number's in the middle? Oh, it's between 2 and 3, right? There's 3 data below, 3 data above. So what number is that? 2.5. And what about up here? The cut would be in between 5 and 5. So the quartile 3 is 5. So quartile 1 is 2.5. The median is 3.5. And quartile 3 is 5. Right? Okay. So now we have to go over here. Well, let's just go over here and answer all the questions that we can. There are how many quartiles that split the data into how many sections? There are 3 quartiles, 3 cuts, which split the data into 4 sections. To find the quartiles, first you have to blank the data from least to greatest. Order it, because we're going to find the median after all. The second quartile is the blank, or middle number when the data are ordered from least to greatest. That's the median, right? You can think of quartile 1 and quartile 3 as the blanks of the upper and lower halves of the data. They're like the medians of the upper and lower halves of the data. So that's a lot of information, but watch this video many times to get it. Now you might be asking yourself, I hope you are thinking about this, what does this have to do with variation? And here's what it has to do with variation. What we're going to do now is we're going to use this first quartile and this third quartile to find out how spread out these data are. Do you remember the range was 8 minus 1? It was the greatest minus the least, so the range was 7. Well, the interquartile range, the range between the quartiles, is the exact same process. But instead of doing greatest number minus least number for the range, the interquartile range, or IQR, is the third quartile 5 minus the first quartile 2. So there's a 3, right? It's a 3 spread between the quartiles. The interquartile range is 3. That's me going over it just kind of without formalizing it, just kind of going over the concept. So we just did this one, right? This was 5 minus 2. And so the interquartile range of the first data set was 3. Okay, for this data set, I believe this was 5, right? And that this was 2.5. And I think the median was 3.5. So for this data set, it's going to be 5, the interquartile range, I didn't even go over this. The IQR, or interquartile range, is the difference between the third and first quartile. So IQR is quartile 3 minus quartile 1. Quartile 3 minus quartile 1. 5 minus 2.5, which is 2.5. Okay, to find the IQR, subtract the Q1, quartile 1, from quartile 3. The larger the IQR, the larger the blank. Well, if this IQR, that distance between the quartiles, is really wide, then the data have more variation. Because variation is the word that describes how spread out the data are. So the larger the IQR, the larger the variation. And if I go back to the essential question, what if the IQR is really tiny? Well, that means that the data are more concentrated. It means more data are all clustered around one value. So this is measures of variation. It's a tough section, a lot of vocab. Watch these videos multiple times. You will get it. Keep it up, everybody. You're doing a great job.